Baronesses and barons of button programming, CircuitPython salutations, it's Prof. G, and in this lesson of CircuitPython School, we'll learn to work with buttons as inputs, and while doing so, we'll also learn how to use conditionals in Python, including various forms of the if statement. To paraphrase the white stripes, this is not the hardest button to button, so let's rock! Now we're first going to code our buttons the standard way, and I want to show you this because you'll see lots of example code that uses this approach. But I also want to show you the limitations of this approach, and then I'll show you an improved way called debouncing, which is often a better choice. Debouncing will be for our next lesson. Now in both examples, we'll start by working with the built-in buttons on our CircuitPlayground. There are two buttons, button A and button B. You'll see them labeled on the board. And to begin programming any sorts of buttons, we need to import the digital I/O library. I/O stands for input-output. Buttons are digital input devices. You press a button, you give input to your board. Now digital I/O is part of basic CircuitPython. It comes with the CircuitPython stubs, so there's no need to import any packages into PyCharm, nor is there a need to import any extra libraries to our CircuitPy board's lib folder. Now to use a button, we need to set up a variable that contains a digital input object so that we can refer to our button in our code. This is going to be very similar to how we set up a pixels variable that was a neopixel object so we could refer to lights. So what we're going to do here is we're going to go into a library. Here it's digital I/O. For our pixel lights, it was the neopixel library. Then we find the class. Remember, a class is a sort of blueprint for creating a data structure. So for our neopixels, the class was capital N neo, capital P pixels. For buttons, the class is digital in out. There's one class for both digital input and digital output devices, but know that buttons offer digital input. Press a button, that's input. Now remember, the class acts like a blueprint, so if we follow the class with parentheses and pass something in, that's sort of like sending it to the class factory so we can build an object from the blueprint. For the neopixel class, we needed to pass in first the location of the lights, so that was board dot in all cap neopixels. That means use the neopixel lights that are on the board, comma, and then we input the number of lights, which was 10. To create the digital in-out object for button A, all we need is the location, and the location of button A on the board can be found by board dot and in all caps button underscore A. Now there's one more bit of setup that we need to do for buttons. Since the digital in-out class can create both digital input objects like buttons and digital output objects like single color LED lights, we need to specify that our button is in fact a digital input device, and we do that with this line. Button underscore A dot switch underscore to underscore input, and in parentheses digital IO dot pull with a capital P dot down with all caps. Button A is just the variable name for the object created above. Switch to input is a function that's available to a digital in-out object. Functions attached to objects are sometimes called methods, and this function or method allows us to switch the digital in-out object so that it is in fact an input. Now this next part is a bit trickier to understand. Technically, there's something called an internal resistor on your board that can hold down an electrical signal so that we can get an accurate reading for the button when it's pushed, but frankly, we don't need to get into the weeds of these electronics at this point in our electronics programming journey. So I'm going to simplify things and tell you just to remember that when you're using internal buttons on CircuitPlayground boards, you need to write the line of code like this. If we were using external buttons that were wired up to our board, like the button that you see here wired to a breadboard that's clipped to one of our CircuitPlayground's pads, then we'd write the same line, but instead of passing dot down in all caps at the end, we'd pass in dot up. And the way that I remember this is that when you wire up a button, you need to pass in dot up. And I'll remind you of this in any future lessons where we work with external buttons. So to set up button A in a CircuitPlayground board, you need these three lines. And I've left a few things out here, so remember you also need to import board. We use that as part of the setup code here. And if you use any neopixels, you need to import your neopixel code into your neopixel setup. But after we've got button A set up, we can check to see if button A is being pushed by checking its value parameter. Dot value. If dot value is true, then the button is being pressed. If it's false, it's not being pressed. Now we call values that are either true or false Boolean values or bools. They're named after the 19th century mathematician George Boole. Cool to have a data type named after you, George B. Bummer you died in 1864 and never got to code in CircuitPython. Now we're going to use that Boolean value dot value, which is either true or false, in an if statement like this. If button underscore A dot value colon. And the way that an if statement works is that if a value or expression being checked is true, in our case, if the dot value parameter here is true, then we're going to execute anything indented under the if statement. If it's false, then we'll skip anything indented and we'll continue on with our code below. So in this example, if the button's being pressed, if button A dot value is true, then we're going to turn all of the lights on our board blue. And because this isn't a while true loop, we're going to continue to check, to check, to check, to check, to check. We'll only turn the lights blue if we press button A. Let's code this up and give it a try. So plug in your board, then launch PyCharm, and if you're new to the playlist, here's where you can catch up on the goodness that brought us all to this point. So let's change the comment to read button-standard, and we need to import digital I/O. So in our import line, we'll say comma digital I/O. I'll keep my NeoPixel code and my color definitions in here, but I'm going to delete everything else. And let's set up our first button. We'll give it a name, button_A is good, set that equal to digital I/O, dot, and the class we want is capital D digital, capital I in, capital O out. Classes are like a blueprint, we'll take that to the factory by using parentheses, and inside we're going to send in the location of button A, which is just board, dot, and in all caps, button_A. Then we need to make sure that button_A is a digital input device. We do that by saying button_A dot switch_to_input. This is a function, or a function attached to an object, which is called a method, and in between parentheses we're going to pass in digital IO dot capital P pull dot in all caps down. We're down with the buttons on our board. Then we'll add our while true loop. Remember that's capital T true with a colon at the end, and this is going to constantly check what's inside it. Then indented below, this is where we're putting our if statement. If button_A dot value colon. So this essentially says if button_A dot value is true. We could also have written this another way with equals equals true afterward, but since this would read if button_A dot value, which is true or false, equals equals true, we're essentially saying if true equals true, so we can get rid of the double equal true and just put in button_A dot value. Then what are we going to do if it's true? Well, when we press return, we're indented. We'll just say pixels.fill, passing in blue in all caps. Then open the terminal and get into TO. I'm already in TO. We'll save. Initially, we see the light on our board is off. But then when I press button A, ho-ho, and it lights up in blue. But hey, it stays blue and the blue doesn't go off. Now before we learn how to fix that by learning more about the if statement, let's give a quick challenge. Modify your code to add a button B, that's the other button in the circuit playground, and if button B is pressed, light up the board in red. So pause, this should be an easy one, give it a shot, resume when you're ready, and let's compare answers. So why don't we use the code you've already written? We can take the two lines used to set up button A, paste them down below, and then change every reference from button A to button B. And just to show you, for board.buttonA in here, if I backspace over button A to the dot, then type dot again, we see all of these board options specific to the Circuit Playground Bluefruit, including button B. And the reason those show up is because several lessons ago, we used the setBoard command to tell PyCharm that we were using this board. Make sure you switch button A to button B in all three places it's mentioned, 2 times with button in lowercase for the name of the button, and once all in uppercase after board, that's the location of the button. Then down here in the while true loop, let's copy the 2 lines for the if statement in here, paste them down below that first if statement, make sure they're outdented so the 2 if statements are even, and we'll say if button_B dot value, and if that's true, we'll set pixels.fill equal to red. Now let's open the terminal with TO, save our work, try things out, and we'll press blue and red and blue and red and blue. And if we press them both at the same time, it gets to be sort of a purple. We'll see why that's the case in just a bit. But if you got this with the blue and the red button working, cool. Now let's see how we can modify our if statement and turn those lights off if no button is being pressed. So let's close terminal, scroll up, and take a look at some slides. So let's take a look at the ways we can expand the if statement, and then we'll code them up. Now one thing we can do is follow the if with an outdented else and colon. So if this is true, in this case if button A is pressed, then we turn the board blue. We execute whatever is indented below the if statement. When we're done with anything in here, we skip past the else and whatever's indented below it, and we continue below. But if this statement is false, meaning the button is not being pressed, then we move to the else statement. We don't execute anything that's indented, and we do execute what's indented below the else statement. In this case, we turn the board black. So either we execute what's here if the statement is true, or we execute what's in the else statement if the if statement is false. Let's quickly try this out. Let's get rid of that second if statement and change it to else colon pixels.fill in parentheses black. And when we run this is what things look like. Press blue, release black, press blue, release black, press blue, release black. So now there's also a clause called elif, and here's how if and elif work together. So if evaluates if this is true, and if it is true, it executes what's indented. If it's not true, it skips this and heads down to elif, and it evaluates if the elif is true. If that is true, then it executes what's indented below the elif statement, and if neither the if or the elif statement is true, nothing indented is executed, and we continue down below. So let's demo this real quick. We'll change the else statement to elif button underscore b dot value. So this is like another if statement that evaluates truth or false. So if button B is pressed, we want to fill in the pixels with red. So let's save and try this out. Value A is true blue, value B is true red, value A is true blue, value B is true red, A blue, B red, A blue, but we've got nothing that's turning it black. Well, we can fix that by adding an else statement. So if the if is true, we execute what's indented below it. If the elif is true, we execute what's indented below it. And by the way, we can add a bunch more elif statements if we wanted to, but if none of the statements are true, we execute what's in the else clause here. In our example, we're going to turn things black. Let's try it out. So we'll add the else clause with pixels.fill passing in black, and let's run this and see the results. Touch A, it's blue. Touch B, it's red. But if nothing is being touched, it turns black. Nice. Now, another thing you might notice is if we press A, it's blue. If we press B, it's red. If we press both, it's blue. Why is that? Well, in this statement, we evaluate all clauses from top to the bottom. If the blue button is pressed, we turn the lights blue and we skip everything below it. Now, what's interesting is when we saw the weird purple earlier in this lesson, we didn't have an elif clause. We had two if statements. So what was happening was A and B were both being pressed, and A and B were being turned on rapidly, really quickly. So blue, red, blue, red, blue, red, blue, red, that made purple. Well, that's interesting, but what if we wanted to say turn the lights green if both A and B were pressed at the same time? Well, we can do that by checking to see if two things are true at once by adding an and clause. So we'll only execute here if button value A and button value B are true. Otherwise, we'll check to see if just A is true. If not, we'll check to see if B is true. And if nothing is being pressed, we'll turn off all the lights by setting them black. Let's try this. So let's change the top if to elif, and then above this we'll add if button underscore A dot value and button underscore B dot value colon, and we'll set it to green with pixels dot fill in parentheses green. Now let's try this out and see how it works. And the colors are hard to tell, so I turned on the lights, but hopefully you can see, there we go, we got green in there when both of them were pressed at the same time. So this is working. We've got our and clause there that executes when both are true, both buttons are pressed. And now before we end, let's try one more example. I want to point out that order matters. So if I cut out the if statement here with the compound conditional with the and condition here and paste it at the end, turn this into an elif, and then turn my first statement in here back into an if where it checks if button value is A, I will never see the green lights go on. And the reason for that is I first check to see if A is pressed. So if I press A and B at the same time, what's going to register is not the third clause, but the first clause. Because if A and B are both being pressed, well, A is being pressed, and the if statement will register because even though A and B are true, we're checking to see if A is true first, and even when A and B are pressed, A is true. We'll never get to that third clause that's got the and condition in there. So hopefully that was clear, and I'm going to undo to go back to the statement that works with the and clause at the top in the if statement. And you know what, before saving this, why don't we change the comment to read ifs and buttons. That'll be the name that we use. And let's save this to the CircuitPython School folder. And as always, make sure that you close up that extra tab so that you're back at code.py. Now, one last thing as we finish up talking about if statements, which are called conditionals in programming. While there's an and clause that evaluates if two things are both true, there's also an or clause that evaluates if one or the other is true. So here are two truth tables for those different conditions. An and clause is true only if both values on either side of the and statement are true. But an or clause is true if either is true or both is true. An or is only false if both sides of the or statement are false. So once again, there was some exceptional big learning in this lesson. We learned how to set up buttons, how to tell if a button was being pressed by examining its value parameter, see if it was true or false. We learned about conditionals with if statements, the if-else, the if-elif, and the if-elif and else, as well as the logical and the logical or, which are used in compound conditions. Hackers, conditions were ripe for big learning, and while we covered the standard method of using buttons in electronics programming, in the next lesson I'll show you a more advanced method that addresses some of the limitations of this most common method that I just showed you. Until then, stay buttoned up and continue to hack.